So today's lesson, or these lessons, the next few lessons actually in general, from 16, 17, and 18, are all going to be dealing with something that we call powers. And powers are what we might relate or might call, normally exponents. And we're going to take a specific look at what a power is. So to start off here is when an integer can be written as a property, as a product of equal factors. Right, factors are just things that we multiply together to come up with an answer. So if they're all equal, so exactly the same, we can write the integer as a power. So if we can write out some sort of integer or some sort of value as a product of equal factors, okay, that means that we can write it as a power. So something like 5 times 5 times 5, which is what we'll look at later on. Okay, if we multiply that together, we're going to get an answer of 125. This we could write out as a power, and we'll look at what that is in just a little bit and what exactly a power is. So a power is an expression which has an exponent on it. Okay, all numbers can be written as a power. If no exponent is shown, then we just default it as a 1, and we'll talk about that in just a little bit. Okay, and how we what that means. Now, like I said before, 5 times 5 times 5, when we multiply it out, is going to give us a value of 125, which is an integer. Now, that integer can be written as a power in a couple different ways, but one of the ways is by writing it out using 5. And so what we're going to do here is 5 is going to be our what we call base, and we'll get into that in just a little bit. And then we have an exponent 3. So it means that we take the 5 and we multiply it out 3 times. These two expressions are equal in value, and so anytime we see something like this is a power. It's the same as writing it out like 5 times 5 times 5, and those answers or that value will be exactly the same. Now, 5 to the power of 3 is the entire power. Okay, so that's what we call that a power. So whenever we see that all together, we call it a power. This includes both the integer and the exponent. Okay, so if we include both of them together, that is in fact the power. The 5, okay, so that integer that we would normally call it is something that we call the base of the power. So the 5 is the base. That's what we kind of, if we call it base upon or kind of hold it upon, that's our base of the power. And this is the value that will be multiplied together 3 times. Okay, so we multiply it together 3 times. It's the base. It's kind of what we root our exponent on, our power on. Now 3 is the exponent of the power. This represents the number of times the base will be multiplied together. Okay, so the exponent represents how many times the base will be multiplied together. As in this case here, we had 5 to the power of 3. 5 is the base, and we multiply it together 3 times. Okay, 1, 2, 3 times. Now, this power can also be described as, and if we call it in words, it would be 5 to the power of 3. The base to the power of the exponent. And that's how we would describe that power. And we could write it out in words exactly like that, 5 to the power of 3. Now, there are a couple other ways of writing things out in words. Okay, so depending on kind of what we have, if we take a look at the area of a square, okay, this can be written as a power of the side length. So the area of a square can be written as a power of the side length. We have 5 times 5, okay, right? That would be how we find the area of that. Or because of the same number, we could write it as 5 to the power of 2. Okay, This will always be written as, and we'll call it x squared, where x is the length of the side. So here, 5 squared. X is just a variable. We'll talk about variables more in the future as well. But it's just the length of the side squared, or to the power of 2. So x is the side length of the side of the square. A power which has an exponent of 2, such as 5 to the power 2, can be described as 5 squared. And I've said that in the past. It's kind of another version of saying 5 to the power of 2. Squared is just another way of saying that, and we use it as kind of a bit of a shorthand, so to speak. So 5 squared is just 5 times 5. And it's because we see this a lot. We do see to the power of 2 a lot, and so it's given kind of a special term, and it's called squared, and it's because it's the area of a square. Both of them are in fact correct answers, and so depending on which you write down, either one of them would be considered a right answer. Now, another special case is a volume of a cube. Okay, it can also be written as a power of the side length. Here you'll notice the side length is 4. To find the volume, and we'll get into this in a little bit later as well, just looking at volume, is length times width times height. Okay, so to find the volume of a cube, the length, width, and height are multiplied together, and you might have done that in the past. Okay, if they're all exactly the same length, it can be written as a power. So something like this here, we have 4 times 4 times 4, which is 4 to the power of 3. The volume of a cube with a side length of 4, okay, which we have here, could be written as 4 to the power of 3, which we did already over here. Now we can, as mentioned, we can describe this as 4 to the power of 3, or more simply, this is 4, and now this is a cube, so we call it 4 cubed. Okay. Now, there are other ways of saying to the power 4, 5, 6, and so on and so forth, but we're going to really not worry about those. Those aren't as common. Squared and cubed are definitely more common, and so we can use the shorthands to recognize squared and cubed. Other ones, don't worry about too much, as those ones we'll just do to the power of, and then whatever letter or whatever number we may have. Now, a number which has an exponent of 1 is just that number by itself. Okay, it's just that number by itself. So if we have something like 4 to the power of 1, that's just 1 4. We're not actually multiplying it by itself at all. It's just 1 4 all by itself. And so it's, again, we don't necessarily have to write out to the power of 1. And so for this reason, the exponent 1 is never written. But is implied. And when I say implied, we understand that 4 is just 4 to the power of 1. Okay, so if when we start talking about exponent laws later on, we're definitely going to be remembering that there is a 1 there, and we have to recognize that. When describing a power with an exponent 1, we just say the number. Okay, for example, 4 to the power of 1 is just 4. All right, let's complete this little chart here with a couple of other ones. So here we have a power. It's negative 2 to the power of 5. And you'll notice that the negative 2 is in brackets. That means that negative 2 is in fact the base. So our base is negative 2, and our exponent is that 5 right there. And if we write out in written form, this will be negative 2 to the power of 5. Okay, that's how we would write out. It's a negative 2 to the power of 5. Now the next one below looks very much the same, but it's slightly different. Okay, and it's important to recognize that it's slightly different because this negative isn't actually on the 2, it's on the power. Okay, So this one, in fact, the base is just 2 and the exponent is 5, but the whole power is negative. So when if we were to solve it, and that we'll get into a little later on, we have to recognize that the negative does not affect or is not a part of the 2, it's a part of the power, and so the whole power is negative. So when we write this out in written form, this would be a negative, and this is where it's going to be very important, comma, 2 to the power of 5. Okay? The negative and the 2 are not connected like it is on top. This is in fact a negative 2. Here it's just a 2, and then it's the power of 5, and the whole thing then becomes negative. Okay? And we'll see a little bit in just a little bit, or in some following lessons, how that's going to be very important when we solve for that. All right, so this is a bit of a longer lesson here, or at least a longer video. In general, it's a shorter lesson, but with a longer video because there's only one. But I'd like you to work on questions 1 to 3. Okay, that's on the back side of this page. Questions 1 to 3, fill in the chart, and then show which is the base and the exponent of specific values, and make sure you write them out in written form. Show everything in written form, no numbers.